Okay, let's take a look at number 5. What I want you to do, hopefully you're watching this because there's a little bit of a change to number 5. After thinking about it and talking to the other teachers, definitely the way this original question is written, the numbers that you have to approximate are insane. And I don't want you to lose the purpose of the question and not be able to complete it because the numbers are out of control. So what I want you to do for number 5 is you're going to have to do some crossing out. I want you to push pause, and I want you to change the numbers to the numbers that you see on the screen right now. So go to number 5 and change up the numbers and change up the A, B, C, D as well. So hit pause and go ahead and do that really quick. Okay, so here are the instructions. It says Polly selects the two numbers with a value between 3 and 5. Now here's the thing. As of right now, I don't know which of these are between 3 and 5. So we're going to have to go through each of these numbers and approximate the decimal or approximate the number so we can tell which two are between 3 and 5. Then it says which inequality correctly compares the two numbers Polly selects. So we can't do that second part until the first part is done. So I'm going to switch over to a page where I can do some work. Again, this might be something, now that you've rewritten some things, if you need to do this on a separate sheet of paper, do it. All right, 2 square root of 3. 2 square root of 3 can be written as 2 times the square root of 3. So my number is going to be 2 times something. This something is going to be the decimal for square root of 3. Now to figure our decimal approximations, what I need to do is I need to figure out which two perfect squares is 3 in between. And I'm going to put them on a number line. Square root of 3 is in between the square root of 1 and the square root of 4. The square root of 1 is 1. The square root of 4 is 2. So my number, square root of 3, is going to be somewhere between 1 and 2. Okay, so this number is going to be something between 1 and 2. Not sure what yet. Now to figure out what number square root of 3 is, now this is an approximation, it's not an exact. You would get a better approximation with a calculator, but you won't be able to use them. So what I'm going to do is I'm going to take this number line and I'm going to break it up so that I have a tick mark for each square root in between 1 and 4. So if you look, all I did was square root of 1, square root of 2, square root of 3, square root of 4. Okay, so I took this, let me change my colors. I took this chunk of the number line between square root of 1 and square root of 4, and I divided it evenly between whatever square roots are in between. So if I look at this as a fraction, this is the whole right here, from 1 to 4, or from 1 to 2. This is my whole. What I need to figure out is how much of that whole does square root of 3 take up? So if I were to fill this into the square root of 3, and I looked at this as a fraction, I have 2/3 of this section is filled up to get to the square root of 3. 1, 2 out of 3. Now I know 1 to 2 is not 3, but if we look at this as sections, I have 3 sections and 2 are filled. So 2/3, so from 1 to 2 on the number line, 2/3 of it gets me to the square root of 3. So what that means is square root of 3 does not equal 2/3. Remember, this is a number between 1 and 2. So it's 1 and 2/3. Okay, let me back up for just a second. Give you a couple reminders. We started at 1. So on my number line, I've already gone to 1. I go to 1, and then I go 2/3 more of the way. So I'm already at 1, then I go 1 2/3 in. So the square root of 3 is about 1 and 2/3. So I can leave this as a fraction and say, okay, well, when I multiply, I get 2 and 2/3. Or I look at this and say, well, 1 and 2/3 is like saying 2 times 1.6 repeating. And 2 times 1.6 repeating ends up becoming, if you want to multiply, you end up with 4, 3, about 3.34. Which, hold on a second, something is not right. Okay, so 2 times 1 2/3, that's 2 times 1 and 2 times 2/3. It's kind of like I'm distributing. When we multiply fractions, let me back up, it would end up being 2 over 1 times 3 times 1 is 3 plus 2 is 5. If you remember your fractions, when you multiply fractions, you have to have fractions. You can't multiply whole numbers and mixed numbers. So I end up with 10/3, which is about 3 1/3. Okay. All right, so 2 square root of 3 is about 3 1/3. Square root of 121 over square root of 4. I can split that up, and I get 11 over 4, which is about, excuse me, it's not 11 over 4, it's 11 over 2, which gets me 5 1/2. Okay. 2 pi. 2 pi would be like 2 times 3.14 something something something. I don't even need you to come up with an actual answer. What you will know is 2 times 3 is 6. So 2 times 3.14 is going to be something bigger than 6. And if you think back to our question, we only want the numbers between 3 and 5. So far, this is out, and so is this. So square root of 21, we need to approximate this again, just like we did in the first one. So I'm going to create a number line, and I'm going to look for the perfect square above, which is 25, the perfect square below, which is 16. So the square root of 21 is going to be between 4 and 5. So now I'm going to count how many spaces in between does it get from 16 to 25. So we've got 17, 18, 19, 20, 21, 22, 23, 24, then there's 25. That happened to work out pretty evenly. So what I need to find out is in between 16 to 25, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 units in between 4 and 5 if I'm looking at square roots. And what I need to find is I need to get myself to square root of 21. So if this is 16, this is square root of 17, square root of 18, 19, 20, 21. So on the number line, square root of 21 would fall here, which is 1, 2, 3, 4, 5 spaces in. So what this is telling me is if this was a fraction bar, I would have 1, 2, 3, 4, 5 out of 9 colored in after the 4. So that means 4 5/9 is the square root of 21. 3 1/3 and 4 5/9 are between 3 and 5, so those are the two numbers we're going to use. So let's go back to our problem. So square root of 121 over 4 is out, and 2 pi is out. 2 square root of 3 was about 3 point something. Square root of 21 was 4 point something. So I'm going to go ahead and say that 2 square root of 3 is less than the square root of 21. You don't even have to be specific because I know that 3 and any fraction or 3 and any decimal is smaller than 4. And that's it.